video, we are going to talk about the cosine rule. So in the previous video, we were talking about the sine rule, and in this video, we will talk about the cosine rule. So cosine rule, again, as well as the sine rule, is a very, very useful tool to find the unknown edges or unknown angles in the given triangle, not necessarily right triangle, but we will consider the right triangle case as well, and you will see how it works and what is interesting about it. But let's first state the cosine rule, and then I will show you how to prove it for one case, and you can repeat the same proof for two other cases. But yes, let's begin. So first, the cosine rule is a very, very useful tool to find unknown edges or angles of the triangle. And let's see how it's stated. So if we are given this triangle, for instance, the triangle, oops, let me make it very nice. So this is our triangle ABC, and I will denote the angles of this triangle also by ABC. So ABC stays for the name of, for the label of the vertices and also for the angles. Now, by lowercase letters A, B, and C, we denote the edges of this triangle. And now let's state the cosine rule, dear students. The cosine rule tells us the following. To find, for instance, the edge A, we can do A squared is equal to B squared plus C squared minus the double product of B and C sides times the cosine of the angle between these two sides B and C. So what is the angle between the two sides B and C? Is the angle C. So we have the cosine C. So again, dear students, the cosine rule tells the following, that the side A squared is equal to the sum of the two sides squared B and C minus the double product of these same two sides B and C and times the cosine of the angle between two of them, which is angle C. Similarly, dear students, the cosine rule can be stated for the side B and for the side C. So B squared is equal the two remaining sides, the sum of the squared of two remaining sides, which are A and C. So it will be A squared plus C squared minus 2 times A times C times cosine of the angle between these two sides A and C. So it's the angle A. So it will be cosine A. And then now we can repeat the same for the third side C. So we'll have C squared is equal A squared plus B squared minus 2 times A times B times cosine of the angle between them, A and B. So it's cosine B. Good. So this is our cosine rule, dear students. And now let me show you how to prove it. It's not that easy, but I'll just show you so you will have the idea how to prove it. So proof. I will prove it. I don't know for which case actually. I don't know how to choose. I'll just sketch the first height randomly, and you can do for other two cases yourself at home. So let me repeat the triangle ABC here with these angles ABC. Again, by lowercase letters, I will label just the size of this triangle. And now, dear students, let me draw the height H as in the sine rule. And for instance, I will draw the height h from the vertex B to the side C, and it doesn't matter. So as I told you, you can draw for other two cases. I mean, you have to be able to prove all these three formulas, but now I'll be proving just one of them. So I just draw one opportunity of this height h from the vertex B to the side C. So again, since this is a height, it creates the right angle between the height and the edge C. So we have here this right angle. And also let me, dear students, put the letter D here. So now we see that this height splits this big triangle into two right triangles, dear students, two right triangles. And again, because we have the two right triangles, we can apply a Pythagorean theorem to both of them. So how do we apply it? So here A is hypotenuse with respect to this triangle, and B is the hypotenuse with respect to this right triangle. So by Pythagorean theorem, and if we consider the triangle, right triangle, A, B, D, we will get the following, dear students. We will get that A squared is equal to H squared. So hypotenuse squared is equal to H squared plus AD squared. But what is AD, dear students? Yeah, of course, we don't know here what is AD. It's some part of the edge C, but we can actually find the very, very nice expression for this side AD, because we know the definition of the cosine of the angle A. So what is the cosine of the angle A? By definition, it is the adjacent side over hypotenuse. So adjacent side here is AD and hypotenuse is A. So from this, it follows that AD is actually A times cosine A. So if now, dear students, plug it back into that formula, we will get that A squared is equal H squared plus A times cosine A squared. So from these, dear students, we will get that A squared is equal H squared plus A squared times cosine squared A. Very good, dear students. So that is our first expression. Similarly, dear students, we will consider this right triangle and apply Pythagorean theorem to it. So by Pythagorean theorem, but now for the triangle BCD, we will get the following. Let's see. This is our hypotenuse. So B squared is our hypotenuse, is equal H squared, our side, plus DC squared or CD squared. Yeah, let me write DC squared just in order. Very good, dear students. But now, similarly, dear students, what we can write here. Let's see. We know that what will be the sine C here. So we can apply it. But we know something else. So yeah, as you can see, dear students, yeah, we can apply what is this. Oh yeah, we can actually do cosine C. It will be this adjacent side over this adjacent side over hypotenuse, but we do not know that cosine C. And in these formulas, dear students, in these cosine rule formulas, we have that we know two sides and we know the angle between them, and we want to recover the third side. So if I already stated here this angle A, it means that I know the sides A and C because the angle A is between them and we want to recover B. So it's actually, since we have this cosine A here, it means that we are recovering B. So actually we are proving this formula. Very good. So having here cosine C in this expression is not good. But what we can do, dear students, let's see what we can do. What is this total edge? This total edge is C. And what is this piece? This piece is A cosine A. So how to find this remaining piece, DC? What is DC? DC is actually C minus AD. But we know what is AD. So it will be C minus A times cosine A. So that is our DC. So if we go back here to B squared, we will get that it will be H squared plus C minus A times cosine A squared. Very good. Now let's work a little bit on this expression. Let's apply some algebra. So we know the square difference formula. So we'll just apply here. So it will be plus C squared minus 2AC cosine A plus A squared cosine squared A. Very good, dear students. So this is our expression number 2. Now let's see, dear students, how these expressions can be combined, this 1 and 2. So what do we have here in each of them? It's our H squared. So if we express from 1 our H squared, we will get A squared minus A squared times cosine squared A. And from 2, we will get H squared is equal B squared minus C squared plus 2AC times cosine A plus A squared cosine squared A. And what we got? We got that left-hand side are the same. It means the right-hand side will be also the same. And also, let me check if I didn't do any mistake. Oh, I did actually. I didn't turn this sign here. It actually will be minus. Good. Okay. So let's, since left-hand sides are the same, it means the right-hand sides will be also the same. So we can just equalize them, dear students, and we will get the following. Okay, so dear students, what we can see here, we have this term and this term which will cancel, and what we will end up with is the following. Let me do the following, so to get the formula stated in the cosine rule. So what I will do, I leave this b squared on the right hand side, but I will move c to the left hand side, and I will move these also to the left hand side. So we will get that b squared is equal actually a squared plus c squared minus 2ac times cosine a. This is what we got, dear students. Let's check which formula we got, 1, 2, or 3 in our cosine rule statement. So we got that the b squared is equal a squared plus c squared minus 2ac cosine a. Very good, dear students. So now to prove the statement 1, the formula 1, or the formula 3, you just do the same approach, but now you have to consider this height and this height. Exactly in the same way as I considered that height. That's it, dear students. So now you see how to get this formula, and the proof is ended. So now let me show you how to apply this cosine rule in dealing with some triangles. So let's consider the following example, dear students. Let's consider example number 1. For instance, we are given the following triangle. So we are given this triangle. And what do we know about this triangle? We know that this side is equal 6 centimeters, this 8, and this 7. What we want to find, dear students, is this angle, which I denote by A. So this is our unknown angle. So how can we find it? Again, dear students, let's look, for instance, I don't know, let's look at these three formulas. First of all, you see, dear students, that if you want to find this, for instance, side A, you need to know what is B equal to, what is C equal to, and what the cosine of the angle C between them is equal to. Similarly, if you want to find the side B, you need to know the two sides A and C and the angle between them. If you want to find the side C, you need to know the two other sides A and B and the angle between them, which is B. Also, if you want to find the angle C, you need to know A, B, and C sides. If you want to find the angle A, you need to know B, A, and C sides. If you want to find the angle B, you need to know C, A, and B sides. So in our case, dear students, we want to find the angle A, so we need to have all other three sides to apply the cosine rule. So let's see how we can apply this cosine rule. So this angle A is given us, the angle that we want to find between two sides, these 6 and 8 side. And this is the opposite. So how can we apply the cosine rule? We know that this opposite side to the angle that we want to find, its square is equal to this side squared, 6, plus this side squared, 8, minus 2 times the product of them, 6 times 8, times the cosine of the angle between them. And the angle between them is exactly the angle we are going to find, which is A. Very good, dear students. So now what remains to us is just find this angle A. But first, to find the angle A, we have to find the cosine A. So we have here that 49 minus 36 minus 64 over minus 2 times 6 times 8 is equal to cosine A. Or we can just write that cosine, we can just write that cosine A is equal to, let's see, 49 minus 36. It will be 9 minus and then plus 4. So it will be 13. So it will be 9 and 4, 13. So it will be 13, and then we have minus 64. So it will be minus 51 over, it will be minus 2 times 6 times 8. So it will be actually plus, and then it will be 12 times 8. So it will be 80. So it will be 96. Oops. Oh, that's kind of. So it will be 96, dear students, 96. Okay, so to find A, now the angle, we just have to find the inverse to the cosine, which is arc cosine of this value. And this value will give us the angle A we are looking for. That's it, dear students. It's pretty, the application of the cosine rule. Similarly, dear students, let's us consider another example when we want to find not the angle, but the side. So if you want to find the side now, dear students, so to find the side, we need to have to be given the angle and two other sides, but the angle between them. So for instance, we want to find, dear students, this side. And we know that this is 5, this is 6, and for instance, this angle is 30 degrees. Oops. That this is 30 degrees. Very good, dear students. Let's find it. Let's apply the cosine rule. So what the cosine rule tells us, let's denote this side by x. So it's unknown, so it's x. The cosine rule tells us that x squared is equal to the sum of other two sides squared. So it will be 5 squared plus 6 squared minus the double product of these two sides, 5 times 6, times the cosine of the angle between them. And what is the angle between them? Is the angle of 30 degrees. So we have to write cosine 30 degrees. So what x squared is equal to now? It will be 25 plus 36 minus 60. Oops. Whoa, this is just something very unusual happening. So it will be 60 here, dear students, multiplied by the cosine 30 degree. And the cosine 30 degree is square root of 3 over 2. So if you just finalize the calculations, dear students, you can find out what this number is equal to. And then to find the side, we just take the positive root of that number, which I denote by, I don't know, let's denote me by some letter. I don't know, some letter F. So that will be just the square root of F. Positive, dear students, because the side cannot be negative. And then it will be some centimeters or meters, that does not matter. It depends what are the measurements of these sides. Is it given in centimeters or meters? It doesn't matter. That's it, dear students. So this is another application of the cosine rule. So here we recover the side, but not the angle. So the last thing that I want to mention here, dear students, is that how the cosine rule will look like if you are given the right triangle, dear students. Let's consider that. How the cosine rule will look like if your triangle is the right triangle. So if we have A, B, and C here, dear students, and we have these small letters A, B, and C to denote the sides. Okay, so the cosine rule tells us the following, dear students. So we have here that B squared by the cosine rule will equal to A squared plus C squared minus 2 times A times C times the cosine of the angle between them, between A and C. But its angle is 90 degrees. So we have to write cosine 90 degrees. But now cosine 90 degrees is 0. So this whole thing will equal to 0. So this will actually, cosine rule gives us the Pythagoras theorem, dear students. So we have here, this is the right triangle with the hypotenuse B, and we got the Pythagoras theorem, dear students. We got that B squared is equal A squared plus C squared. And similarly, dear students, if you have the right triangle now, but the right triangle with, for instance, here A, B, and C. And now I will denote the sides as C, B, and A. So now if you repeat the same application of the cosine rule here, you will get that A squared is equal B squared plus C squared. So you see that whenever you have a right triangle and you want to apply this cosine rule, for that side that lies in the opposite to the right angle, you will get the Pythagorean theorem. Yes, dear students. But of course, if you consider the cosine rule for this side A, it will be A squared equal B squared plus C squared minus double product of B and C times the cosine of the angle between them, which is not 90 degrees. So that will not disappear if you want to apply a cosine rule for the side A. But for the side B, yes, it will disappear. And you can see it because this is right triangle and this is the hypotenuse. So you will get just a Pythagorean theorem. That's it, dear students. So let me remind you what we covered in this video, dear students. In this video, we covered the cosine rule and how it can be applied to the triangle. Like what can we find given the triangle and some partial information in it, what can we recover? With applying the cosine rule, we can recover the angle or we can recover the side based on what we are given and what we want to find. Thank you very much for your attention.